So, calorimetry. Calorimetry is pretty much measuring the amount of heat transferred during heat transfer, such as a chemical reaction or a phase change. Usually, you use a calorimeter to measure how much the temperature changes after a reaction, which you then use to calculate the amount of heat that was transferred. And how do you calculate this? By using some equations, which you actually have on your reference tables underneath the heat section. You can pull it up right now if you want to see for yourself. The first equation is Q equals mc delta T. The reference table tells you that Q is a heat, m is a mass, C is a specific heat capacity, and delta T is the change in temperature. You need to remember the units. The heat is in joules, the mass in grams, the specific heat capacity in joules per gram Kelvin, and change in temperature is in Kelvin. Or Celsius, because Celsius is the same as Kelvin when you're taking the change in temperature. Finally, you need to know that the change in temperature is calculated by taking the final temperature minus the initial temperature. Again, these temperatures must both be in Kelvin or both be in Celsius. And now you can go ahead and calculate the heat to Q when you plug in everything over here. And just like any equation, if there is any one value you don't know, you can plug in the other values to find it. But just one more thing. You need to know that the mass and specific heat capacity that you use must be the mass and specific heat capacity of the thing that is changing in temperature. That thing is usually water, so usually you would use the change in temperature of the water, the mass of the water, and the specific heat capacity of water, which is actually on table B in your reference table, 4.18 joules per gram Kelvin. And now an example. How many grams of water can be heated from 22 degrees Celsius to 57 degrees Celsius using 1600 joules? Let's start with our equation, Q equals mc delta T. It asks for the grams of water, so we're looking for the mass m. We just need to plug in the other values first. The heat Q is 1600 joules, the specific heat capacity C is 4.18 joules per gram Kelvin, which again is in your reference table. And since we're given the final and initial temperatures, we can turn delta T into Tf minus Ti. The final temperature is 57 degrees Celsius and the initial temperature is 22 degrees Celsius. We can calculate the change in temperature to be 57 minus 22, which is 35 degrees Celsius. Then we can solve for m. You should end up getting about 11 grams of water as your answer, correct to 2 sig figs. But you might notice there are 2 more equations listed on your reference table. There's Q equals mHF and Q equals mHV. You already know what Q and M are, and the reference table tells you HF is the heat of fusion, while HV is the heat of vaporization. Now, these 2 equations are used for heat transfers in phase changes. So the heat of fusion one is for changing between solid and liquid phases, while the heat of vaporization one is for changing between liquid and gas phases. Again, you'll usually be looking at phase changes with water, and if you look under table B on your reference table, you'll find the heat of fusion and heat of vaporization for water. 334 joules per gram for the heat of fusion, and 2260 joules per gram for the heat of vaporization. And notice that temperature isn't in the equation. This is because here the phase changes, but the temperature doesn't change. If the temperature changes, you'll need to use the first equation that we did. So let's finish with a quick example. How much heat is required to melt a 2.3 gram block of ice? Here we're melting, so a phase change from solid to liquid, which means we need to use the heat of fusion. It asks for the heat required, so we're looking for Q. Now plug in the other values. The mass is 2.3 grams, the heat of fusion is 334 joules per gram. We multiply, and our final answer is 770 joules, correct to 2 sig figs. And that's it.